So, have you ever tried to get a single AI bot to do something really complex? Yeah, it usually ends in total chaos, right? Today, we're going to move past those simple single agents and dive into the world of agentic swarms. These are highly coordinated AI systems that can actually tackle sophisticated projects, but to build them, you need a blueprint. So let's get into the architectural patterns that make it all possible. Here's what we're going to cover. First, we'll dig into why agent chaos is even a thing. Then we'll look at the patterns for structuring the swarm, building out its operational core, and putting up the guardrails you absolutely need. And finally, we'll bring it all together so you can see how to design your own system.
All right, let's get right to the heart of the issue. There's this fundamental problem with the idea of a single, do-it-all, generalist AI trying to handle everything we throw at it.
And it all boils down to this one question, really. How can an AI that's brilliant enough to write a poem just completely fall apart when you ask it to manage a multi-step software project? The answer to that is exactly why we need a whole new way of thinking about architecture.
This slide really says it all. Look at the difference. A generalist bot, it suffers from what's called context bloat. It's trying to know everything at once, so its focus gets watered down. That leads to low accuracy and, frankly, unpredictable results. But a specialized agent, it has one job. It's focused, its accuracy is way higher, and you can actually rely on it. So the solution isn't just a smarter agent, it's a smarter system of agents.
So, how do we build that smarter system? Well, we start with the foundational patterns. These are what give our swarm its basic structure and stop it from turning into that chaos we talked about.
The first pattern is maybe the most important one. It's all about division of labor. Instead of giving one agent a huge, messy project, you break it down into smaller, bite-sized subtasks. Then, you create a unique, super specialized agent, what we call a granular persona, that is perfectly built for each one of those tiny jobs.
So here's how that workflow actually plays out. First, a task decomposer agent looks at the big project and just chops it up into logical pieces. Then, a persona designer agent steps in and creates the perfect specialist for the job. You know, like a coder agent and a critic agent. And then crucially, a scope validator makes sure that no single agent is being asked to do too much or juggle conflicting tasks.
Now, for those of you building really advanced systems, here's a little pro tip. You can actually automate this with something called an entropy monitor. Just think of it like an automated manager that notices when one of its team members is getting overwhelmed. As soon as it sees an agent's job is too broad, it automatically splits that agent's duties into two more focused sub-agents. It's like specialization on the fly.
Okay, once you have all your specialists, you have to control how they talk to each other. Otherwise, you're right back to chaos. That's where orchestration topology comes in. For a simple, predictable task, a sequential chain is fine. Agent A does its thing, then passes it to Agent B. But for more dynamic, messy problems, a hierarchical structure with a manager is way more effective.
And that idea of a hierarchy leads us straight to the manager agent. Think of this agent as the team lead or the project manager. It doesn't do any of the coding or writing itself, it just oversees the worker agents. It delegates tasks, makes sure everyone has what they need, and pulls all the final results together. It's pretty much the central nervous system for the whole team. And here's where it gets really powerful. You can build in a self-correction loop. So if a worker agent keeps failing a task, let's say 3 times in a row, the manager agent can automatically fire it, spin up a brand new one, and reassign the task. This creates an incredibly resilient, self-healing system. It's a great example of a core principle here. Always be pruning the system to make it better.
Okay, so we've got our swarm structured. Now we need to give it the infrastructure to actually do stuff, to remember things, use tools, and do it all without breaking anything. This is what we call the operational core.
These 4 patterns are absolutely essential. You've got a shared workspace, which is like a common brain, so every agent is on the same page. Persistence management gives it long-term memory. A tool registry lets agents use real-world tools securely, and sandboxed environments make sure that any code they write is isolated and can't cause any damage.
It is so crucial to understand the 2 types of memory here. Think of session memory, that shared workspace, like a whiteboard in a meeting. It's temporary, it's just for the task at hand. But persistent memory, that's the project archive. It uses a real database, so that if a project takes days or weeks, the agents don't forget what they were supposed to be doing in the first place.
Let's look at a pretty cool advanced feature for that tool registry. Instead of an agent just grabbing whatever tool it wants, you can use a tool broker. This broker can analyze a task and suggest the smartest, most cost-effective option, like, hey, maybe run this simple local script instead of making a super expensive call to an external API. This optimizes everything for both performance and cost.
Right, our swarm is structured, it's operational. Now we got to talk about management and safety. These are the patterns that make sure the final output is actually good and that the system doesn't go rogue and do something dangerous. Okay, this one is one of my personal favorites, the Critic Agent. You're basically building an automated QA tester right into your swarm. So when a coder agent says it's finished, it's not actually done. The work immediately gets passed to a Critic Agent, whose one and only job is to poke holes in it, to find bugs, flaws, and logical mistakes.
And this chart shows you the goal perfectly. The system can do what's called a recursive critique. The coder and the critic go back and forth, making the work better and better, until the critic's confidence score about the quality hits a certain target, like 95%. Only then is the task marked as complete.
But let's be realistic. Some actions are just too risky to let the AI do all on its own. And that's what Pattern 9, Human in the Loop, is for. For low-risk stuff, like just logging some data, sure, let the system do it automatically. But for high-risk actions, we're talking deploying code to a live server or moving money around, the system has to stop and get a mandatory sign-off from a human. It's a non-negotiable safety valve.
And that brings us to our 10th and final pattern, which really ties this whole thing together. As the saying goes, you cannot improve what you do not measure. You have to track your system's performance, otherwise you're just flying blind.
This is how you make your system smarter over time. By tracking key metrics, you get a really clear picture of how things are going. For instance, how many tokens, which means how much money is it costing you to get a task done? And what's your success rate? What percentage of tasks get finished without any failures? By logging all this, you can spot the bottlenecks and re-architect the weak spots, making the whole swarm more efficient over time. Okay, we've covered all 10 patterns. So now the big question is, how do you actually put this all into practice? How do you pick the right combination of patterns for your project?
Well, this table is a great little cheat sheet. For basically any complex task, you're going to need those structuring patterns: decomposition, orchestration, and a manager. If your agents need to remember things or use external tools, then you'll pull in the operational patterns. And if quality and safety are top priorities, which they should be, then you absolutely have to implement the governance patterns.
And that brings us to the final and maybe most important piece of advice here. Don't try to build the most complicated system imaginable on day one. Start simple. Build the most basic thing that can solve your problem. Then, as the problem gets harder, you can start adding more patterns and more complexity. Just remember to let the problem you're trying to solve be the guide for how your AI swarm's architecture evolves.